Welcome to Radiography Professor Explains. I'm Dr. Delia Lofton, and today we're breaking down AC, DC rectifiers and rectification in X-ray circuitry, and why they are essential for proper X-ray production. Before we discuss rectifiers and rectification, we first need to understand the difference between alternating current, or AC, and direct current, or DC. These concepts are important because the X-ray imaging system receives AC electricity, but the X-ray tube requires current to flow in only one direction for proper X-ray production. Let's begin with alternating current, or AC. Alternating current is electrical current that periodically changes direction. In the United States, the electrical power supplied from a standard outlet operates at 60 Hertz. This means the AC waveform completes 60 cycles every second. During each cycle, the voltage changes polarity. It moves through a positive portion of the waveform, returns to zero, moves through a negative portion, and then returns to zero again. So, with AC, both the magnitude and direction of the electrical current continually change. AC is useful because its voltage can be efficiently increased or decreased using transformers, which is extremely important in X-ray circuitry. Now let's compare AC with direct current, or DC. Direct current flows in only one direction. Unlike AC, DC does not periodically reverse direction. A common example is a battery, which supplies current with a consistent polarity. This one-directional flow is important when we consider the X-ray tube because electrons must travel from the cathode to the anode. Remember, cathode is negative, anode is positive. Electrons produced at the cathode are repelled by the negatively charged cathode and attracted toward the positively charged anode. The electrical power entering the X-ray imaging system is alternating current, but there's a problem. Because AC periodically reverses polarity, we cannot allow it to pass through the X-ray tube unchanged. During the appropriate portion of the electrical cycle, the cathode is negative and the anode is positive. This allows electrons to travel cathode to anode. But when AC reverses polarity, the anode would become negative and the cathode positive. This creates inverse voltage across the X-ray tube. We do not want electrons traveling in the opposite direction. That's where rectifiers and rectification become important. A rectifier is an electrical device that allows current to flow in only one direction. Think of a rectifier as an electrical one-way valve. It prevents current from flowing through the X-ray tube in the wrong direction. Rectification is the process of converting alternating current into unidirectional current, so keep these two terms separate. Rectifier is the device. Rectification is the process. In the X-ray circuit, rectification ensures that electrons travel through the X-ray tube in the desired direction, cathode to anode. One method is half-wave rectification. Remember that an AC waveform contains both positive and negative portions. With half-wave rectification, one half of the waveform is allowed to pass through the circuit, while the opposite half is blocked. Therefore, only one half of the original AC waveform is utilized. The resulting current is pulsating but unidirectional. Next is full-wave rectification. Instead of simply blocking the negative half of the AC waveform, full-wave rectification inverts that portion of the waveform. This allows both halves of the AC cycle to contribute to X-ray production while maintaining current flow in the proper direction. This makes full-wave rectification more efficient than half-wave rectification. Modern X-ray systems typically use high-frequency generators. In these systems, the incoming AC power undergoes several electrical conversions. The voltage is rectified, electronically switched at a very high frequency, transformed to the high voltage required by the X-ray tube, and rectified again before being applied across the tube. This produces a tube voltage with very low voltage ripple. Because the voltage remains relatively close to the selected kVp throughout the exposure, high-frequency generators provide more efficient X-ray production than older single-phase generators. Let's connect the concepts. AC periodically changes direction. DC flows in one direction. A rectifier is the electrical device that controls the direction of current. Rectification converts AC into unidirectional current, and in the X-ray tube, rectification ensures that electrons travel in the proper direction from the cathode to the anode. Here's a simple way to remember these concepts. AC changes direction, DC flows in one direction, transformers change voltage, rectifiers control the direction of current. And ultimately, rectification protects the X-ray tube from inverse voltage and ensures the proper electron flow necessary for X-ray production. Understanding these relationships will help you see how the X-ray circuit ensures electrons travel properly from the cathode to the anode for X-ray production. Thanks for watching Radiography Professor Explains. If you found this helpful, like, subscribe, and share, and I'll see you in the next lesson.